For APCalculus Notes 9.2, this is 2 of 4 video, and we're looking at examples here using the terminology we just learned in the previous video, and we're focusing on degree measures. Draw an angle in standard position. Well, you need to know what standard position is. That means the initial side is on the positive x-axis, vertex at the origin. I can just go ahead and draw that for each of these, the initial sides, and identify the quadrant in which the terminal side lies. Negative 12 degrees means that I'm going to rotate in the positive direction. This doesn't have to be perfectly to scale. Like so. What quadrant is that? That's in quadrant 4. Number 2 is 570 degrees. Now your choices are, you can find a coterminal angle to 570 and draw that. It's going to be in the same location. Or you can just draw the 570. I highly recommend that you label the quadrantal angles, especially if the angle that you're doing is bigger than 1 revolution. And when I get to 360, I still haven't got to this 570. So 360 more is 450. I'm sorry, 90 more than 360 is 450. 90 more than 450 is 540. And 90 more than that gets me to 630. So that means when I draw this, I go complete revolution and I get 360, 450, 540, 570 is going to be here in quadrant 3. So I made a complete revolution and then I got to here for my 570 degrees. That's going to give me an angle in quadrant 3. If I wanted to find a coterminal angle here at the beginning, it's an alternate method. I could have taken 570 minus a complete revolution. That would have gotten me 210 degrees, which would end up being in the same location. Find the measure of each angle in degrees. Well, if we look at number 3, this angle here is 30. Now we know that it's 180 from here to here, and we are 30 degrees short of that 180. That makes this 150 degrees. Looking at number 4, this angle here is 15 degrees. This angle here is 90. So this together must be 90 plus 15, which is 105. And you got to be careful. This angle in standard position goes in the negative direction. So that means this is 105 degrees negative style. Number 5, we made a complete revolution. It's 360 degrees plus 90 more, 450 plus 90 more is 540. So we're at 540 when we get to here. And then this is 90 degrees. We've used 70 of that. That means there's 20 degrees left. So 20 and 540, that makes this 560 degrees. Number 6, we are going in the negative direction. So we got negative 360, negative 450. Just going to label that. And then we went 25 more degrees in the negative direction. That's going to get us to negative 475 degrees. Number 7, find one positive angle and one negative angle that is coterminal with each angle. Well, to find a positive coterminal angle, I'm going to take this 100 and I'm going to add a revolution to it. Someone else could have added 2 revolutions to it, or 4 revolutions, or 1,000 revolutions. There's an infinite number of correct answers for this. To find a negative coterminal angle, I'm going to subtract a complete revolution from this. I get negative 260 degrees. Someone else could have added multiple negative revolutions. Number 8, let me change this problem a little bit, make it something better. Let's say that it was negative 721 degrees. Find a coterminal angle between 0 and 360 degrees. Well, if I take negative 721 and I add to it a complete revolution, that is not going to give me an angle between 0 and 360. If I add 2 revolutions to this, it still won't as well. So I'm going to, just for illustrative purposes, I'm going to add 720 degrees. That is 360 times 2 is what that is. That would give me negative 1 degree. Still not between 0 and 360. I'm going to add another revolution to that, and that's going to give me 359 degrees. Negative 721 degrees is coterminal with 359 degrees, which is between 0 and 360. Number 9, find all angles coterminal with this angle. There's an infinite number of these angles. But here's how we can do this using mathematics. Take the angle we're given, and we add a complete revolution, 360 degrees, times n, where n is any integer. Symbolically, I wrote n as any integer. This is n. This is an element of, looks like a C with a little horizontal in it, and z is the set of all integers. If you don't like this, then you could write where n is any integer. I wrote where n is in the set of integers, which is more succinct. That's why I like it, because I am a laserama. 10, 11, convert to degrees, minutes, and seconds. All right, so it's already in degrees. 64.34567 degrees. That means we have 64 complete degrees. If we want to change this decimal, 0.34567. If we want to change that, which is currently in degrees, into minutes, we're going to multiply this by a fraction that's equivalent to 1. For a fraction to be equivalent to 1, the top and bottom have to be equal. 1 degree is equivalent to 60 minutes. Those are equivalent things. So if I do this, my degrees are going to cancel. If I put this in my calculator, I'm going to get 64 degrees plus 20.7402 minutes. That gives me 64 complete degrees, 20 complete minutes, and then I have this decimal in minutes that we want to change to seconds. I'm going to multiply this by a fraction in the form of 1. 1 minute is equivalent to 60 seconds. If I do that, my seconds are going to cancel once again, or my minutes are going to cancel. So then if you multiply in your calculator this times 60, our final answer is going to be 64 degrees, 20 minutes, and 44.4 seconds. Your degrees, nearest whole number, your degrees round down to the nearest degree, your minutes round down to the nearest minute, your seconds round to the nearest tenth. Do the same process for 11. Essentially what you're going to do is you're going to start out with your negative 45 degrees. You're going to take this decimal and multiply it by 60, and it give you 15 point something. You take whatever that decimal that it gives you, which I believe is 0.3 repeating, multiply that by 60, and you're going to get 20 seconds. Don't include the negative in your calculator. Use the negative here with the degrees. The rest of this is all in the negative direction. We don't need to include multiple negatives. 12 and 13, convert to decimal degrees with a precision of 2 decimal places. So here's what we do. Take the negative and put it on the outside, or don't even put it in your calculator at all. We got 7 plus, if you want to change minutes into degrees, you're going to divide by 60. If you want to change seconds into minutes, you divide by 60, and then change that into degrees, you divide by 60 again. Essentially, you're dividing it by 3,600. This ends up being negative 7.35 degrees. We usually do 3 decimal points. This direction says 2. That means I need to change the directions, quite frankly. This next one is going to be 120.89. Do it in the same similar way. You got 120 plus 53 over 60 plus 22 over 3,600. That in your calculator, and you'll get 120.89. That concludes video 2, dealing with circular, trig, and degrees. The next video, we're going to learn what a radian is.